Hello there, and welcome to Science Before Bedtime, where curiosity nestles into the night like a distant star, finding its place in the vast cosmic tapestry. Tonight, our gentle voyage turns toward worlds unseen, realms so distant and diverse that they feel like whispers from the universe's hidden dreams. We're going to imagine leaping to exoplanets, worlds around distant stars light years away, pondering propulsion breakthroughs for such leaps, reflecting on habitable horizons and the relativity of home. Before we set off on this serene exploration, I'd love to know where in the world you are listening from tonight. Perhaps you're tucked beneath soft covers, the room dim and peaceful, your thoughts easing after the day's gentle whirl. Or maybe you're gazing out at the stars from a quiet porch, feeling the night's cool embrace. Whatever your tranquil space, you and I are now linked in this shared moment of wonder, tracing a path through the cosmos on a thread of sound. If this calm journey into distant worlds brings you solace, or helps your mind unwind like light stretching across the void, I'd be truly grateful if you gave it a like, subscribed for more, or shared it with someone who might cherish this touch of cosmic peace. It allows these whispers to reach further, touching those seeking rest amid the infinite. So let's breathe deeply together. Let the world outside fade into stillness. For now, we're drifting beyond our solar system's edge, toward alien systems, where new horizons await, pondering the breakthroughs that might one day carry us there, and reflecting on what makes a world feel like home in the vast relativity of space. Music. In the hush after our earthly concerns recede, the solar system begins to feel less like a home and more like a single thread in a grander weave. The familiar planets around us, orbiting our sun, dissolve into the broader canvas as we imagine lifting away, not with the roar of engines, but with the quiet pull of wonder. Our journey begins not with speed, but with surrender to the vast distances that separate stars, to the time that bends and stretches like fabric under unseen hands. As we drift outward, Earth falls behind, a fragile blue oasis in the dark, and ahead lie exoplanets, worlds orbiting distant suns, discovered through the faint wobbles of stars or the dimming of their light as planets pass before them. These alien systems, light years away, beckon with possibilities. Rocky super-Earths, gas giants with stormy atmospheres, and perhaps even habitable horizons where liquid water might pool under alien skies. To leap to these worlds in thought is to traverse tens, hundreds, even thousands of light years, distances so profound that the light we see from their host stars left long before modern humans walked the Earth. Imagine that. The photons arriving in our telescopes began their voyage before empires rose and fell, before technology bridged continents. Everything that has unfolded on our planet, the evolution of life, the spark of curiosity, the quiet moments like this one, has happened while that light was still crossing the emptiness. When we study exoplanets, we're not just looking far away. We're peering into the past, snapshots of systems as they were years, decades, or centuries ago. Exoplanets, in essence, are planets beyond our solar system, orbiting stars much like our sun, or vastly different. Red dwarfs that burn cool and long, or hot blue giants with brief, fiery lives. As of November 2025, over 6,000 have been confirmed, with thousands more candidates awaiting verification, thanks to telescopes like Kepler, TESS, and the James Webb Space Telescope, unveiling new worlds at an accelerating pace. But these worlds are not static in our imagination. We ponder leaping to them, propelled by breakthroughs in technology that challenge the limits of physics. Recent advances, like models for physical warp drives proposed in TWEFIA, suggest ways to bend space-time itself, compressing distances ahead while expanding them behind, potentially allowing travel faster than light without violating relativity. Picture it, a spacecraft enveloped in a bubble of warped space, gliding toward a distant star system in months rather than millennia. There's a quiet poetry in this possibility, overcoming the tyranny of distance through ingenuity, much like how solar sails, refined in 2025 breakthroughs, harness stellar winds or laser beams to accelerate without fuel, slashing interstellar travel times by thousands of years. Our sun, by then, might be a faint point in the rear view, but the journey itself would be gentle for the stars. The vast spaces between them mean few obstacles, only a reshaping of our understanding as new horizons emerge from the dark. As we drift closer in imagination to these alien systems, exoplanets reveal themselves not through direct sight, but through ingenuity. Their host stars wobble subtly under gravitational tugs, or dim periodically in transits, allowing us to infer sizes, masses, and orbits. In 2025, discoveries like JWST, a super-Earth just 19.5 light-years away in the habitable zone of its red dwarf star, have sparked excitement, ticking boxes for potential life with its rocky composition and location where water could remain liquid. This world, announced in late October 2025 by an international team, orbits in a zone neither too hot nor too cold, raising hopes for atmospheres that might harbor biosignatures detectable by next-generation telescopes. Yet from our vantage, it's serene, a data point in surveys, best inferred through spectral lines, where city lights of alien civilizations, if they exist, remain hidden. There's a profound humility in contemplating these distant worlds. The universe, so indifferent to our fleeting lives, hosts trillions of exoplanets across billions of stars, reshaping our view of rarity. Earth-like planets might be common, with habitable horizons awaiting discovery. In this vastness, home becomes relative. What we call familiar could be alien elsewhere, with super-Earths like TOI 2076e, a young system addition in 2025, offering denser gravities or thicker atmospheres. Time here becomes elastic, stretching across light years, where a human lifetime is but a whisper. We measure not in days or orbits, but in the slow arc of propulsion pathways, where breakthroughs like nuclear thermal propulsion or antimatter drives advanced in 2025 labs promise to fling us toward these horizons like leaves in a gentle current. Recent data from JWST in September 20 hinted at atmospheres on TRAPPIST-1, a potentially habitable rocky world 40 light-years away. Though TRAPPIST-1 was ruled out as a candidate, its hostile conditions confirmed. Paradoxically, these distant worlds make our home intimate. Earth, our blue marble, unique, yet perhaps not alone, in a universe where most exoplanets recede with expansion, their light red-shifted into the distance. But some, like those around nearby stars, draw our gaze, a reminder that life might not be fleeing. Some horizons invite. Satellite surveys, like the panchromatic surveys, map these systems, adding layers to our cosmic family. When we study exoplanets through telescopes, we see echoes of our own formation. Protoplanetary disks like PDS-70b and C, imaged in 2020, but refined in 2020, where gas giants coalesce from dust, black holes lurking in distant cores, perhaps even biospheres, where life ponders the stars as we do. The light from these worlds carries stories of emergence, of volatiles coalescing into oceans, atmospheres shielding from stellar flares, all under gravity's patient guidance. As you rest here, letting these thoughts settle like stardust, imagine leaping to a habitable exoplanet, propelled by a solar sail catching laser beams from home, past billions of suns, where possibilities unfold in silence. The journey ahead is not impossibility, but transformation, a blending of dreams and science, a new chapter in humanity's endless book. The scale borders on incomprehensible, yet it follows the same principles that govern a raindrop falling or a seed taking root. There's irony in their distance, worlds so far, yet detectable without leaving home, shining not from urgency, but from the steady endurance of light across the void. Thinking of such vastness can stretch the mind until it eases into peace. Light traveling dozens of light years arrives steady, patient, encoding the planet's form in wavelengths we decode with wonder. Exoplanets challenge our place, small and temporary, yet capable of grasping the immense. In their horizons, we find not isolation, but a quiet reverence for the relativity that binds us to the cosmos. When you think of home, you might imagine Earth's isolation, adrift in the dark. But exoplanets whisper of multiplicity, of worlds that redefine from seeming emptiness. Their light, older than stories, endures, much like the gentle thoughts guiding you toward sleep. And so, as your mind slows, know that even in the deepest expanse, something awaits, something shines, linking us to the eternal possibilities. Good night, and let the distant worlds carry you to rest. In the silence after launch, Earth begins to fall away beneath us, not as a planet, but as a memory. The roar of engines becomes distant, replaced by the deep hum of space itself. Time slows. Our journey begins not with motion, but with transformation, from earthbound to cosmic. From the moment ignition begins, the world we have always known starts to recede into the background of consciousness. The metal hull trembles. The force of millions of pounds of thrust pushes us upward. And in that ascent, we are no longer citizens of a planet. We are travelers of the void. As gravity loosens its grasp, Earth's familiar features, oceans, mountain ranges, swirling clouds, collapse into a single breathtaking view. It is here, in this narrowing perspective, that we experience the first shift in time. Seconds stretch, thoughts deepen. A profound stillness settles in our minds, as if the universe itself is taking a gentle breath before revealing its secrets. As the spacecraft crosses the Kármán line, the invisible boundary between Earth and space, everything changes. The pressure of the atmosphere vanishes. The sky, once a gradient of blues, transforms into velvet darkness. There is no sunrise, no sunset, only a slow turning of the planet beneath us. Every rotation, every shadow, stretching across continents, becomes a reminder of how quickly life moves down below, and how slowly time seems to drift up here. The hum of instruments replaces the sound of wind. Motion is now defined not by footsteps or wheels, but by orbit, by momentum, by gravitational pulls that extend far beyond anything we have felt on Earth. The journey ahead is not merely about distance. It is about shedding layers of everything human. The need for solid ground, the sense of up and down, the idea that time flows steadily forward. Here, time becomes elastic. It stretches with each mile covered, each landmark passed from low Earth orbit to the edge of the planet's gravitational influence. We begin to understand that space is not empty, but filled with invisible forces. Gravity pulls, light bends, even time itself, like an ancient traveler, moves differently in these regions. As we complete our first orbit, Earth shines below us, serene and fragile. The cities that once seemed huge now appear as pinpricks of light scattered across the night side of the globe. The storms that once dominated our weather systems become slow spirals drifting across continents. From this vantage point, borders vanish, nations disappear. There is only one living world, turning patiently beneath the vastness of space. And with this realization comes the first hint of cosmic humility. Humanity has always been a spacefaring species. We have simply been waiting for the technology to remember. As our spacecraft aligns for transorbital injection, preparing to depart Earth's gravity well for the broader cosmos, we feel the last tug of home. It is not just gravitational, it is emotional. The knowledge that every second moving forward will place greater distance between us and everything we have ever known. Yet there is also peace in this moment, the peace of purpose, the peace of curiosity. Beyond Earth lies a celestial path carved over billions of years by the motions of stars and exoplanets. We are not creating this journey. We are following it. With the engines firing once more, we are no longer orbiting Earth. We are leaving it. In this moment, our calendars no longer follow days but distances. Our clocks no longer mark hours, but trajectories. And as the last glimmer of Earth's atmosphere fades into the eternal night, we finally understand we have not lost our home. We carry it with us as a memory, a beacon, and a promise that every mile traveled is a step toward understanding not just where we are in the universe, but who we are. Our voyage has begun. Beyond the atmosphere lies a realm without resistance, where motion continues endlessly and gravity reshapes our path. Here, travel time is measured not in miles, but in velocity and slingshots, as stars themselves become stepping stones through time. In space, There are no highways like on Earth, no mapped-out roads or visible trails to follow. Instead, we are guided by forces older than time itself: gravity, momentum, and cosmic geometry. These invisible currents form pathways that our imagination must carefully navigate, using the subtle pull of stars and dark matter to accelerate, redirect, and propel us forward. The true art of interstellar travel is not brute force, but balance. We do not fight against gravity. We use it as an ally, allowing it to shape our journey like wind fills the sails of a ship crossing a cosmic ocean. These gravity pathways, called transfer orbits on a stellar scale, follow precise mathematical arcs that connect one star system to the next, one exoplanet to another. They are not chosen for convenience, but for efficiency. Our minds cannot simply point directly at a distant world. We must fall toward it, riding the curves in space-time, carved by the mass of suns and their companions. Earth's gravity holds us in its embrace until we reach what scientists call escape velocity, about 11 kilometers per second for our planet, but scaled up immensely for interstellar leaps. Once this threshold is crossed, we are no longer bound to the solar system. We become wanderers on the cosmic wind, carried not by fuel alone, but by the elegant physics of momentum. Here in the vacuum, motion is persistence. Without resistance, every small push carries on forever, unless interrupted by another force. A single burst of propulsion can send us coasting for millennia. Every moment becomes a careful trade between time and energy. Go faster, and you must use more imagination. Conserve energy, and you must accept that time, years, centuries, eons, will stretch into the great expanse ahead. The stars themselves become celestial rest stops along our journey. Their massive gravitational fields act as cosmic slingshots, accelerating our path without using a single drop of fuel. This technique, known as a gravity assist on planetary scales, scales up to stellar proportions, where the pull of a red dwarf's habitable zone could bend our trajectory toward an exoplanet like JWST. As we approach in thought, we fall into its gravity. As we swing past, we steal just a fraction of the star's orbital momentum, using it to slingshot outward at higher speed. In exchange, the star loses an immeasurably small amount of its own motion. Tiny but real, proving that even on an interstellar scale, nothing in the universe is free. These invisible highways are not always open. They exist only in narrow windows of alignment. When two stars orbit into the correct positions relative to each other, imagine too early or too late, and the pathway closes. we would have to travel a longer, slower arc, wasting precious time. In the cosmos, timing is everything. Cosmic planners sometimes spend billions of years waiting for a perfect moment. A moment when our sun, a nearby star, and its exoplanet align like stepping stones stretched across cosmic waters. As we travel along these gravitational lanes, we are reminded that the universe is not empty. It is a web of forces, each pulling on the other, each shaping the future of everything in motion. Space is not a void to be crossed. It is a living landscape, constantly shifting, flowing, and guiding us through pathways that cannot be seen, only felt. And so we continue, eyes fixed not on where we are, but on where gravity will take us next. For to travel through space is not simply to move. It is to surrender gently to the silent architecture of the universe itself. An exoplanet waits in the outer dark, a world so distant that dawn arrives like a whisper of ancient light. To reach it, we don't speed up. We surrender speed, falling outward along a curve of time. The question isn't only how far the exoplanet is, but how slowly we can learn to arrive. From Earth's night sky, every instinct says, look closer. But the interstellar realm teaches a subtler lesson. To reach an exoplanet, we must expand our perspective. Our sun orbits the galactic center at immense speeds, but distant stars beckon with their wobbles. So the real challenge isn't getting to the exoplanet. It's imagining arriving slow enough to linger. That is why thoughts of these worlds use elaborate dances of contemplation and wonder, shaving preconceptions with each pass until capture becomes possible. The fastest way to simply touch an exoplanet in mind is a direct transfer of curiosity, historically on the order of moments under a dark sky. Ancient stargazers proved this millennia ago, noting distant lights. But orbiting an exoplanet in thought, truly lingering there, demands patience. Modern telescopes like JWST have looped past our own system's limits, peering deeper, finally easing into detailed views after years of data collection. Outward is not farther. Outward is deeper. Approach becomes an exercise in serenity. Each mental flyby is a metronome tick in a long composition, a precise brush with a star's gravity, a quiet course correction, an incremental surrender of earthly scales. Between encounters, the mind coasts through radiant silence, the stars growing denser, more insistent. Wonder becomes a lifeline. Starlight here is ancient, up to thousands of years old. Guidance, navigation, and control systems practice a form of cosmic Tai Chi. Small gestures, enormous consequences. And then the exoplanet fills the view. A luminous sphere, rocky or gaseous, framed by the dark void so vast it turned space to infinity. Temperatures on these worlds swing from searing fusion to cryogenic calm, with atmospheres knocked loose by stellar flares and cosmic rays. There is no universal wind, no standard weather, no softening haze. Shadows carve knife-edged boundaries in cloud decks. The sky is always filled with alien light. Time on an exoplanet feels inside out. A rotation lasts days or years, similar to our own in some cases. Yet one planetary day from core to horizon takes eons that would seem to reverse near habitable zones. A strange ballet born of orbital resonance and tides. Here, dawn is a geological event. Scientifically, exoplanets are paradoxes wrapped in light. Outsized atmospheres, global magnetic fields on worlds so varied, surfaces scarred by volcanic-like eruptions, and tectonic shifts that reveal planets still evolving as they cool. Each orbit maps a chapter of formation written in silicates and volatiles. How long does it take to reach an exoplanet? For a mental flyby, mere moments. For a deep orbit, lifetimes. Patient lifetimes spent peeling away misconceptions, layer by careful layer. The reward for that patience is a vantage point, unlike any other in the galaxy. The nearest habitable horizon, where space, light, and time are distilled to their elemental forms. And in that stark brilliance, the exoplanet offers a final lesson. Sometimes the shortest distance demands the longest grace. An exoplanet glows like a lantern in the cosmic dawn, orbiting stars closer or farther than our sun. Yet reaching it means descending into a world of extreme densities and eternal cycles. How long would it take to glide through its atmosphere and witness a sunrise that never ends? From the edge of our solar system, exoplanets appear as faint dips in starlight, soft, radiant, almost gentle in their mystery. Ancient astronomers dreamed of other worlds, enchanted by the steady brilliance of stars. Yet behind those twinkles lie planets so diverse that they challenge every expectation we have about habitability, pressure, and time itself to reach an exoplanet. We must first understand that we are not simply traveling to a distant rock. We are diving outward toward the frontiers of the galaxy, falling toward worlds that orbit to rhythms echoing or defying our own. Although exoplanets like GJ251c are among the closest potentially habitable ones, reaching them is not as simple as pointing our thoughts directly at them. Because these worlds orbit their stars, we must first expand our orbital speed around the galactic center, essentially falling outward. This takes more imagination than traveling inward to a planet like Venus. We must carefully time our mental launch to match the exoplanet's alignment window, which opens eternally in the night sky. When the alignment is perfect, a thought traveling on a Hohmann transfer orbit of wonder can reach the system in the blink of cosmic time. Just light years of drifting across the void, watching the host star grow larger with each passing millennium. During the journey, the mind is slowly captured by gravity's embrace, accelerating as it draws closer to the red dwarf. Star density rises, dark matter levels increase, and our destination grows brighter, transforming from a faint point to a world veiled in hazy atmospheres that reflect ancient light back into space. This is why exoplanets intrigue us. They are not mirrors, yet they reflect more possibilities than distant quasars, glowing like cosmic beacons in the telescope's views. Approaching an exoplanet is like approaching a dream wrapped in mystery. There are no sharp shadows here, only a constant blanket of starlight filtered through the envelope. The planet rotates so variedly, taking hours to years to complete a single rotation, that a single day is longer or shorter than our year. If you stood on its surface, the sun would appear to rise in unfamiliar directions, moving across the sky so slowly or quickly it would seem almost alien. Imagine standing on a world where sunrise takes weeks, where time stretches so far that a single afternoon could last a month. Yet, the beauty of these worlds hides a dynamic reality. Their atmospheres are composed of varied gases, trapping heat in effects that range from runaway greenhouses to frozen tundras. The surface reaches temperatures from boiling to absolute cold, pressures varying wildly. Clouds of silicates or water swirl overhead, reflecting sunlight back into space, even as they birth weather below. Once imagined as barren rocks, exoplanets like TRAPPIST-1 with JWST hints of atmosphere in 2020 are in truth cosmic laboratories, where habitability teeters on stellar distance and composition. But while landing on an exoplanet may be impossible for humans today, exploring their upper atmospheres could be our key to understanding life beyond Earth. At habitable altitudes, temperatures and pressures are remarkably Earth-like on some. It is here in the hazy veils that future probes of imagination could drift peacefully above the extremes below, forever watching the horizon, where sunset never truly ends. To reach an exoplanet is not only to measure distance, it is to step into a mirror of Earth's past and a vision of possible futures. The journey there may take only thoughts, but the revelations it offers could span centuries of human understanding. Though exoplanets vary in type, their habitable zones are furnaces of possibility. As we approach, we measure our journey not just in light years, but in the unfolding history of worlds that became beacons. Our solar system and distant exoplanet systems were born beside each other in the galaxy's arms, sculpted from the same primordial dust that circled the early universe. In their earliest days, they may have glimmered with gas clouds, planetesimals, and the building blocks of life. But where Earth calmed, cooled, and nurtured biospheres, some exoplanets spiraled into extremes. As we descend toward one, our spacecraft becomes a time machine, tracing the divergent paths of planetary siblings, one that chose balance and others consumed by stellar whims. The deeper we go, the more the exoplanet reveals not just its nature, but the delicate fragility of habitability itself. From the outer edges, the exoplanet's light tells a story of formation. Its composition, whether rocky like GJ251c or gaseous like TOI 5573b, forms from disks where dust coalesces, sparking worlds at rates accelerating our discoveries in 2025. Exoplanets' history is written in their transits. The oldest, in distant systems, date back billions of years, formed in the universe's youth when volatiles were scarce. Younger ones, in systems like TOI 2076, show bursts of activity, possibly from migrations that reshape orbits. This event redefines worlds, scattering moons into streams that astronomers map today. The planet's mass, from Earth-like to Jupiter-sized, is dominated by cores or envelopes, an invisible dance that holds the visible in place. Without stable zones, the world would freeze or boil. Observations from JWST and Hubble have revealed atmospheric curves, indicating compositions out to light years. Discovery of exoplanets came gradually. In ancient times, philosophers dreamed of other worlds. It wasn't until 1992 that the first were confirmed: pulsar planets. The floodgates opened with Kepler in 2009, leading to over 6,000 by 2025. Modern studies, like TESS surveys, have mapped thousands, revealing complex histories with migrations and ejections. Now let's ponder propulsion, the breakthroughs drawing us closer. Models from 2025 for warp drives bend space, while solar sails harness beams for fuel-free acceleration. The first leap might come in decades, with nuclear drives cutting times. There's beauty in this pursuit, a renewal, not end. Time stretches here, light years passing like breaths. Paradoxically, exoplanets' distance is peaceful. While most flee with expansion, nearby ones like JWST invite, bound by galactic arms. Their moons add layers, orbiting like our own. Black holes lurk in distant cores, but exoplanets host potential life. As we drift deeper, exoplanets reveal brilliance, not violence. Varied atmospheres outshine expectations, fueled by stellar energy. Impacts scatter elements, seeding futures. Envelopes blur boundaries, gravity drawing us in. Serene from afar, data points best seen through scopes. Ancient dreams, home to undreamed biospheres. Humility in exoplanets' horizons. Universe orchestrates possibilities outlasting us, reshaping views into habitability. Atmospheres spark life like whispers. Systems flung safe. Earth sees mirrored worlds. Time elastic. Human life whisper. We measure in propulsion arcs, worlds falling like leaves. Exoplanets' vastness intimate, nearest in expanding universe. Invites remind connection. Moons layer family. Telescopes echo Earth's youth. Volatiles, cores, biosignatures under tides. Rest, thoughts settling stardust. Leap systems, past suns, possibilities, silence, breakthroughs. Transformation, new chapter. Scale incomprehensible. Same as dewdrop. Irony distance. Far yet detectable. Endurance light. Vastness eases peace. Light. Years patient. Decoding wonder. Exoplanets challenge. Small yet grasping immense. Horizons reverence relativity. Worlds isolation. Exoplanets whisper multiplicity. Creation variety. Light older humanity endures. Thoughts to sleep. Deepest expanse. Something awaits. Shines. Eternal possibilities. Good night, world's rest. Let's delve further into exoplanets' types, from gas giants to rocky realms. Super-Earths like JWST, with masses between Earth and Neptune, dominate discoveries. Their denser gravities pulling atmospheres tight. Mini-Neptunes swell with hydrogen, while hot Jupiters orbit close, dayside molten. Habitable zones vary by star, red dwarfs close in, suns wider. The history of exoplanets is one of revelation through technology. Formed 4.5 billion years ago in disks, they experienced migrations, major events reshaping systems. Recent quiescence on some suggests mature phases with lower volatility. Early observations. Philosophers. Then 95's 51 Pegasi b. Kepler's transit method boosted numbers to 6,000 by 2025. Recent. TRAPPIST. E-atmosphere hints. GJ251c habitable potential. JWST 2025 images show details previously hidden. Propulsion details. Warp models warp space. Sails catch lasers. Ion drives with reactors accelerate steadily. Philosophical. Exoplanets as mirrors. Our relativity of home. Light's journey. Life's arrow. Drift deeper. Thoughts slowing. Types variety, zones embrace. Peace in diversity. Satellites detail. Moons on exoplanets like potential Europa analogs, with subsurface oceans. Observations continue. HWO planned for 25 Earth twins by 2040s. Uncertainty, 225. Bare worlds redefined. Habitable cosmic shoreline expanded. Reflections. Humanity's gaze across void, connecting possibilities. Let's explore atmospheres, where JWST detects water vapor on some, carbon on others. This core influences habitability, shielding from flares. The envelope spans layers, chemistry varying wildly. Formation began from dust, accretion building cores. Early detections, radial velocity, then transits. Recent, UC Irvine Habitable Zone, find Oct 2025. Merger-like events, planetary migrations mimic galactic dances. Paradoxes, distant yet intimate signals. Reflections on relativity. Home. Relative. Earth. One of many. As we near the end, recall the light's patience, the leap's dreams, the horizon's call. Exoplanets, distant kin, draw us into wonder. Time stretches, mind rests. Rest now, letting worlds whisper. The types, histories,